The smallest particle of an element, atom. An atom is the basic unit of matter that makes up everything around us. Imagine trying to pack a suitcase for a vacation, but you can only fit so much before it becomes too heavy or doesn't close. Just like each item in your suitcase is essential for your trip, each atom is the essential building block of matter, determining the characteristics of the element. In this analogy, just as the suitcase represents the entirety of your travel needs, an element is made up of countless atoms, with each atom being the smallest unit that still retains the element's properties, similar to how each packed item maintains its individual purpose within the larger context of your trip. A negatively charged particle outside the nucleus of an atom. Electron. An electron is a tiny particle that orbits the nucleus of an atom and carries a negative charge. Imagine trying to find a parking spot in a crowded city where all the good spots are taken, and you have to circle around the block multiple times. In a similar way, electrons are like these cars trying to find a place around the atom's nucleus, constantly moving and never quite settling in one spot. Just as cars are negatively impacted by the frustration of limited parking, electrons are negatively charged and are bound to the nucleus by the attraction. But never get too close, always staying outside and moving around it. An uncharged particle in the nucleus of an atom. Neutron. A neutron is a subatomic particle found in the nucleus of an atom that has no electrical charge. Imagine you're at a party where everyone has strong opinions, but you're the one person who stays neutral and doesn't take sides. Just like you at that party, a neutron is a particle in the nucleus of an atom that remains uncharged and neutral. In this analogy, the party represents the nucleus of the atom. The people with strong opinions are like protons with a positive charge, and you, the neutral partygoer, are like the neutron, maintaining balance without adding any charge. The center of an atom nucleus. The nucleus is the dense core of an atom where protons and neutrons are located. Imagine trying to organize a chaotic closet where everything is scattered, and finding what you need is nearly impossible. Just like organizing your closet requires a central spot to anchor everything around, an atom's nucleus serves as the core structure that organizes the surrounding electrons. In this analogy, the nucleus is the neatly arranged center of the closet, like a sturdy shelf or a set of hooks, providing order and stability, while the electrons are similar to the items hanging or placed around it, ensuring everything stays in place and functions efficiently. A particle with a positive charge in an atom's nucleus. Proton. A proton is a subatomic particle found in the nucleus of an atom that carries a positive electric charge. Imagine trying to find the right key in a cluttered drawer to open your front door. Just like the key is essential for unlocking the door and letting you into your home, a proton is crucial in an atom's nucleus, giving it a positive charge that helps define the identity of the atom. In this analogy, the key represents the proton's positive charge needed to unlock or stabilize the atom, while the cluttered drawer symbolizes the nucleus filled with different particles, where protons stand out by defining the element and interacting with electrons to maintain balance. The region around an atomic nucleus where electrons are likely to be found, electron cloud. An electron cloud is the area around an atom's nucleus where its electrons are most likely to be located. Imagine trying to predict where your pet cat might be lounging in your house at any given moment. Just like the cat can be found in a few favorite spots, but you can't pinpoint exactly where it is at all times, electrons around an atomic nucleus exist in a cloud where they are likely to be found but aren't in one fixed location. In this analogy, your house is like the atom, The cat's favorite spots are comparable to regions within the electron cloud where electrons are more likely to be, and the uncertainty of the cat's exact location mirrors the uncertainty of pinpointing an electron's exact position around the nucleus. A region of an atom where electrons with the same energy are found. Energy level. An energy level is the specific area around an atom's nucleus where electrons orbit based on their energy. Imagine you're at a crowded concert where everyone with the same type of ticket is grouped together in specific sections. Just like how ticket holders are organized by sections based on their ticket type and price, electrons in an atom are organized into energy levels based on their energy. In this analogy, the concert venue is like an atom, the sections represent energy levels, and the ticket types correspond to the energy of the electrons, grouping them together in specific regions. Number of protons in an atom's nucleus. Atomic number. The atomic number is the count of protons in an atom's nucleus, determining the element's identity. Imagine you're at a large conference trying to find your friend among a sea of attendees. Similar to how each unique outfit or accessory helps you identify your friend, the atomic number of an element helps identify the element itself. Just as your friend's distinctive features or attire distinguish them from the crowd, the number of protons in an atom's nucleus defines the element and distinguishes it from others. The average mass of all the isotopes of an element. Atomic mass. Atomic mass is the weighted average of the masses of all naturally occurring isotopes of an element. Imagine trying to figure out the average cost of a grocery bill when sometimes you shop for a family gathering and other times just for yourself. This is similar to how scientists determine the atomic mass of an element, which is the average mass of all its isotopes, each with its own grocery bill of mass, depending on how frequently it shops or occurs in nature. Just like you might spend more overall on groceries when you shop for a family gathering compared to just yourself, an element's atomic mass takes into account the spending or contribution of each isotope based on how commonly it is found, much like calculating an average grocery cost over time. A substance made of one type of atom that cannot be broken down chemically. An element is a basic building block of matter with unique properties. Imagine you're trying to untangle a pair of headphones that have become hopelessly knotted. Just as each knot can be seen as a simple, singular obstruction, an element is a basic substance made of only one type of atom that cannot be broken down into something simpler chemically. In this analogy, the headphones represent matter, and each knot corresponds to an element, which, like the knot, cannot be simplified further without losing its identity. An atom of the same element with a different number of neutrons. Isotope. Isotopes are variants of the same chemical element that have differing numbers of neutrons, which can affect the element's stability. Imagine you're trying to find your friend in a crowd, but they keep changing their outfit. This situation is similar to trying to identify isotopes of the same element, where each isotope has a different number of neutrons, much like your friend changing outfits. Just as your friend remains the same person despite changing clothes, an element remains the same element even though its isotopes have different neutron counts. The difference in clothing is like the difference in neutron numbers. The sum of neutrons and protons in an atom's nucleus. Mass number. The mass number is the total count of protons and neutrons present in the nucleus of an atom. Imagine trying to make a perfect sandwich by balancing just the right amount of bread and filling. Similarly, the mass number of an atom is like this perfect sandwich, where the bread represents protons and the filling represents neutrons. Just as the sandwich's overall weight depends on the right combination of bread and filling, an atom's mass number is determined by the sum of its protons, bread, and neutrons, filling in the nucleus. Just as the sandwich's overall weight depends on the right combination of bread and filling in the nucleus.